Hello everyone, welcome back to Coding Theory Guru. So in today's video, we are going to understand CPU burst time and IO burst time in operating system. Okay. So CPU burst time and IO burst time, when a program runs, it doesn't just keep using the CPU all the time. A program usually does two types of work. First is CPU work, calculations, processing, logic. Example is adding numbers, sorting data, running algorithms. So this period when the process is actively using the CPU is called a CPU burst. Then IO work, input output operations. Example is reading from a file, writing to disk, waiting for user input, sending data to a printer, downloading from the internet. So this period when the process is waiting for or performing IO operation is called an IO burst. See. So first let's understand what CPU burst time means. So basically whenever a process is performing calculations, okay, performing calculations or like running logic or executing instructions on the processor, that time is called a CPU burst. Okay, CPU burst, for example like adding numbers, sorting data or running a program's algorithm. Okay, then we have IO burst time. IO burst time. Okay, so whenever a process is waiting for input output operations like reading a file or writing to disk, printing a document, or like waiting for user input, that period is called an IO burst. Okay, now see key points. A process alternates between CPU burst and IO burst. Example of a cycle: first is CPU burst, then IO burst, then CPU burst, then IO burst. So in the end, termination. Some processes are CPU bound, spend most time in CPU burst. Some processes are IO bound, spend most time waiting for IO. See, basically a process never uses only CPU or only IO. Okay, so it always alternates between CPU burst and IO burst. So the cycle looks like this. First is CPU burst, then IO burst, then CPU burst, then IO burst until the process finishes. Okay, then example, see, imagine you are preparing a report. Okay, so first you calculate data in Excel, that's a CPU burst. Okay, then you save the file to disk, that's an IO burst. Okay, so next you again run formulas, CPU burst, and finally you print the document, IO burst. Okay, so like processes keep switching between CPU burst and IO burst. Some processes are like CPU bound, they spend more time on CPU burst, or while others are IO bound, they spend more time waiting for IO operations. Okay, now see visual flow: CPU burst, IO burst, then CPU burst and IO burst. Okay, just like, see, what is a actual burst, what is a burst? Okay, so the word burst means a short period of intense activity. Okay, in operating systems a process never keeps using only the CPU or only the IO devices continuously. Okay, so instead it alternates between short periods of CPU execution and IO operations. So these short periods are called burst. Okay, so in CPU burst time, a CPU burst occurs when the process is actively using the CPU. So during this time the process executes instructions, perform calculations and carries out logic. Example like sorting a list, adding numbers, compiling code, all these are CPU burst. So CPU burst time equal to the time spent by the process in the CPU. Okay, and other hand, IO burst time. So after CPU execution, process often need input or output. So this could be reading a file from a disk, writing results, waiting for keyboard input, or like sending data over the network. Okay, so during this time the CPU is usually idle for that process because it is waiting for IO to complete. Okay, so IO burst time equal to the time spent by the process in IO operations. Okay, so like a process always alternates between CU burst and IO burst until it finishes. Okay, like CU burst, then IO burst, then CU burst, then IO burst. Okay, and in the end, termination. Okay, so basically, see, example step 1 is a program performs calculations, hits CPU burst. Okay, then step 2, it saves the data to disk, IO burst. Step 3, it again processes data. Okay, then CPU burst. And step 4, finally it prints the result, means IO burst. So this alternation continues until the process is completed. Okay, and time types of process are like depending on where most of their time is spent. Okay, or basically processes are categorized like two terms. First one is CPU bound processes. Okay, so in CPU bound processes spend most of their time in CPU burst. Example like complex calculations or like mm, machine learning algorithms, simulations. And the other hand, IO bound processes spend most of their time waiting for IO. Example is file transfer, database queries, web servers. Okay, so basically these distinctions is very important for scheduling algorithms in operating systems. Okay, so why is this important? CPU burst or IO burst. Basically, scheduling algorithms like FCFS, SJF, or round robin and priority scheduling depend like heavily on how long CPU bursts are. Okay, basically scheduling algorithms like SJF, round robin, FCFS. So priority scheduling depend heavily on how long CPU bursts are. So the efficiency of system depends on balancing CPU bound and IO bound processes. Okay, if like too many CPU bound processes run together, so CPU gets overloaded, or if too many IO bound processes run together, means CPU site idle. Okay, so that's why operating systems must handle CPU burst time and IO burst time smartly to achieve maximum utilization. Okay, so basically CPU burst time means time spent by a process executing on the CPU. CPU burst time means time spent by a process executing on the CPU. And IO burst time means time spent by a process waiting for a or performing IO operations. Okay, like process alternate between CPU and IO burst until completion. And some processes are CPU bound and some are IO bound. Okay, thank you.